So good evening once again. Today we're going to continue our discussion on, I think we left off with the scheduling problem. So there are many problems about this in LP. This is just a very basic example. You'll have a case which will be more complex and which will involve, say, a cost component, because this does not even consider the, let's say, the overtime, the premium if you're working at this particular time frame. So this is highly simplified. And once again, let's quickly review what this problem is all about, which we have already created the LP for this, right? So just a quick review. We're told that the employees report for work either at midnight, 4 a.m., 8 a.m., noontime, 4 p.m., or 8 p.m. And employees stay or are at work for 8 hours consecutive. So if they report for work at 12 midnight, then they leave the work at 8 a.m. Okay. So we also have requirements as far as the manning is concerned during particular time periods. So you can see here that from 8:01 to 12 noon, there's a greater demand for people, most probably because of the lunchtime, and also for from 4:01 to 8 p.m. 19. Okay, the least number is from 12 to 4, which is 3. So we would like to determine the number of employees that will report for work on the specific time frames. So we have defined that to be number one, Schedule 1. We just named it Schedule 1, or which is the employees to report at 12 midnight up to Schedule 6, the number of employees to report at 8 p.m. So we have 6 decision variables. And then we said that the objective here is to minimize the total number of employees. So this is manning. Okay. If we were given, for example, the cost component, then we would have.
Sir,
Yes.
sir, sorry, are you sharing your screen?
Am I not? I'm sorry.
No, sir.
Sorry. Okay. Apologies, guys. Grabe. Kala ko na share screen na ako. Okay. Ayan. Thank you for reminding me. Okay. All right. So this was what I was showing, what we were working on last time. This is problem number 3 in our workbook. Okay. Decision variables are schedules 1 up to schedule 6, which is we'd like to determine the number of employees to report at 12 midnight up to 8 p.m. Right? And then the objective is simply minimize the overall number of employees. So here, overall number of employees is to be held at a minimum. So it's just actually the summation of all your schedules here. Schedule 1 plus Schedule 2. Take note that Schedule 1 refers to the number of employees to report at 12 midnight. So be very careful with how you design your decision variables. Okay. So remember last time when we were trying to set up our constraints. Okay, I think we proposed multiplying, for example, 3 times what Schedule 1, for example, and we said that doing that will not result to any meaning at all. Okay, so be very careful with setting up your of course your decision variables, your objective function, and then the constraints, definitely, because wrong, if we're wrong in any of this, then it will mean, of course, even if we correctly run the solution, then it will be meaningless. Okay? It will be irrelevant and of no use because we're solving the wrong problem. Okay, and then given these constraints, Schedule 1 plus Schedule 6, there should be minimum number of 3 employees. How did we get this? This is coming from this constraint that from 12:01 to 4 a.m. there should be a minimum number of 3. And we know that during this time period, the employees who will be there at this hamburger stand are those coming from Schedule 1 and Schedule 6. So we define this to be Schedule 1 and Schedule 6 should be greater than or equal to 3 because the constraints is minimum number. All right. So I think I told you to change this because okay, let me just do that. 8 to 12. Okay. And then this one should be 1201 to 16. Okay, and this one will be Dali, ah.
Pwede. Okay.
Okay, Shelly, mute muna kita. ah. Okay. All right. So we have here 1201 to 16, 1601 to that's what's that? 4 to 20, okay? Plus 4. And then here is 2001 to well, one again 0 0, okay, or 12 midnight. Okay. And and schedules I, where I ranges from 1 to J, should be greater than or equal to 0, which means they should be positive. You cannot have a negative answer here. And we have to impose this because these constraints do not necessarily guarantee that the values of our schedules, of the different schedules. Okay, I think this is also wrong. Schedule 1 plus 6, and this should be schedule, please correct me if I'm wrong, is this 1 plus 6 and then 1 plus, tama ba to? 1 plus 2, and then this should be 2 and 3. So let me just correct this. This should be schedules 3 and 4. Kindly correct me, class, if I'm wrong. This is schedule 4, sched 4, and sched 5, and then sched 5 and 6. Okay, I think that's it. 1 and 6, 1 and 2, 2 and 3. Okay. All right. So for this one, it's just the sum. Okay, so maybe I should. Okay, maybe I should. Okay, let me just write that. Sched 1 plus sched 2. Just copy this. Control C. Then so this is 2, 3, 4, 5, and then 6. Okay, so we are to maximize. Sorry, minimize. Okay, minimize Z, where Z is your, okay, it's your function of adding all the number of people who report for work at the different time frames. Okay, let me pause for a while and maybe request your feedback if the LP is clear so far. Could you kindly chat, please? Yes, kung clear, or if you have any questions about it, thank you. Okay, thank you. Thank you so much for your feedback. Okay, so once the LP has been set, the rest is just it's a matter of just creating cells for your decision variables. Okay, so you can work even with this, with the data that's given. Okay, so this can be your because this is the constraint, right? These are constraints. We have this right-hand side constraint, so you just have to add the left-hand side. Okay. So there are different ways to do this, and what I'm going to do now is I'm just going to maybe copy this, Control C, and then put it here, somewhere here. Okay, put it up here. Control V. Okay. So let me just abbreviate this a bit. Minimum number. Okay. Minimum number of employees required. All right. Then let me just increase the size a bit. Okay. So I'll just work with this. Minimum number of employees. I just work with this data here, and let me just format this a bit. Let me just get the border out. Oops. Okay, let me just for aesthetic purposes and for, okay, all right. So what I'm going to do is I'm going to work with this data table, and then this I know is my right hand side, right? If I take a look at my constraints, it's my right hand side. This one greater than or equal to 3, greater than or equal to 5, and again, I'm sorry, I should be 3, 5, 13, 8, 19, 10. Okay, I failed to 3, 5. What's the next one, class? 30, is it 13? 3, 5, 13. Let me just correct that. 8, 19, 10. This one is 8, 8, and then 19, and then 10. Okay. All right. So we're ready to solve this. Now, again, it's it's really up to you how you will set up your model. Perhaps what I'm going to do is I'm just going to pattern it after this one. Okay, so I'll put here sched1. I think I have the word sched1. All right, I'll use this. Control C, Control B. And as I said, each decision variable should have its own cell. Okay, I'm going to use this. Okay. Let me see if I can copy the format here. Okay, there. All right, then this is my number. Okay, number of employees. Okay. And then I'll put here the time schedule. Okay, time schedule. So these are our decision variables, and as I said, we have to color code it. I prefer color coding it in light blue to mean it's a variable. It's like the water that changes. Okay, so pardon my analogy. Okay, and then we need to also have our objective function. I can put here total. It's just the sum. Okay. Let me just highlight everything here so that I have the same font size. Okay. So out equal to, shortcut for sum. All right, there. And then I'm going to format this. Again, when you do your work, kindly follow this format so that I also know. Let's just make it a convention for our class so that I know what is your decision variables, what is your constraint. Okay. All right. So what do we now have? We have our decision variables. Okay. We have our constraint, which is, sorry, we have our objective function, which is the sum of schedule 1, schedule 2 until schedule 6. Okay. And then, okay, I'll give you a few minutes, class, to set up your objective, your left-hand side for your constraints. So if I look at this, if we look at this once again, this is our left-hand side. This one, schedule 1 plus schedule 6, that should be greater than or equal to 3. Okay, so let me pause share, and then let me pause recording. I'll give you 1 to 2 minutes, please, to set up your objective function. Please remind me to continue recording later. Recording and resume share and stop share.
Okay. I'll share my screen, sir.
Yes, please. Thank you. Thank you.
Okay. Is my screen visible now, sir?
Yes. Okay. Thank you.
Okay. So I set up my LP like this. So
Okay.
I plotted the whole schedule kasi medyo graphical ako mag-ano.
Okay. Sure. Sure. Pwede yan.
I visualize it this way now.
Yeah,
Yes, sir.
okay.
So ito yung variable ko nasa baba.
Okay.
Yung employees reporting per shift, tapos naka-refer yung mga schedule dito sa taas, no? So for example, for shift 1, who will be the present employees? It will be those reporting in shift 1, 2, and then in schedule 6 as well. Tapos
Okay.
ganun siya, sir. Tapos alisin ko muna yung solution, sir.
Okay. Go ahead.
Tapos dito sa baba, sir, nandito yung yung constraints. So ito naka-refer to dito sa K33 kasi yun nasa K33 siya yung total nung
So what's in K33?
total of employees present on a
Okay.
particular shift, sir. So
Alright.
dito nakikita, sir, na those who will be reporting in schedule 1 and schedule 6
Okay.
will be the one who will be counted for the first shift, and then sa schedule 2, those who will be reporting in schedule 1 and schedule 2 as well.
Okay.
And then given this parameters, I will run the solver and then solve. And sir, the optimal number of employees to be hired is 35 employees, sir.
35.
Tapos given yung number of employees reporting per schedule. So for example, in schedule 1, 3 will be needed to report for that particular time, and then for schedule 2, 13, schedule 3, 0, schedule 4, 9, schedule 5, 10, and then schedule 6, 0, sir.
Okay. May question lang ako. Yung sa for your E32, E33, where is that coming from? Pakiano nga.
E33, sir, is
E40. Saan yung
yes,
E40?
ito,
E40.
E40, sir, ito, sir.
There. Okay. Kasi that's your decision variables.
Yes, sir.
And then also, you have also E40 for E34, right?
E34 is also referred to
E33.
Yes, sir.
Wait. E30. Wait. How did that happen? So,
E33, yes, sir, is referred to E40.
E40. And
And
then
then E34 is referred to E33. Kasi, sir, di ba yung...
Okay. Pero why not refer it also to E40?
Kasi, sir, initially, I set the variable dito sa E33. Pero to make it
Okay.
parang magkakasama dito sa baba,
Mm-mm.
I created another.
So which means that you could still change this yung sa E30, yung sa E34 that can refer to E40, is that right?
Yes, sir. Yes, sir. Tama po kayo,
Okay.
sir.
Kasi it might, okay, tama naman yung ginawa ni Erwin, ano yan. That's correct. Kaso nga lang, this might cause confusion, no? Kasi, di ba, yung sinabi ni Erwin na yung the one in E32 is equal to E40, pero the one in E34 is equal to E33. So, that there might be a danger that this might become circuitous, no? Yung umiikot siya, no? That can happen. But turns out that okay naman yung solution ni Erwin, which is very good. Okay. All right. So you have your decision variables there. Then you have your total your objective function, right? And then where's your
Yes, sir.
left-hand side, Erwin?
This one, sir. Number of employees.
No, yung left-hand side itself. Highlight that, yung left-hand side mismo.
Yes, sir.
Where's your left-hand side? Not that one, yung cell mismo. The cell.
This one, sir.
That's that one. Color code mo rin yan, ha?
Okay,
Also,
sir.
Parang brown din, no? Same as the
Brown,
objective
sir.
function. So that we will have the same color as the objective function.
Okay, sir.
Okay. So in your cases, class, when you do your model, I want this type of a formatting because it will be easy for me to identify where are your decision variables. Your objective function also, please color it red, the 35, the font
Okay, sir.
there. Okay.
Yes,
So
sir.
immediately I can see that 35 is your objective function because of color coding and font formatting. Okay. All right. So this is okay. So thank you, Erwin. The solution, I think, is 35. I also got 35. Okay. So thank you, Erwin.
Thank
Good.
you, sir.
Great. Salamat. Now let's see if your other classmates, Jovil, could you also share your answer? Let's see if any similarity or difference.
Yes, sir.
Sige,
I'll share my
please.
screen.
Okay. Thank you.
Here, here's the screen. Here, right
Okay.
now. That's also my solutions.
All right. This is another way, you know, but
Yes, sir.
we get exactly the same answers. Sige, please
Yes, sir.
identify your decision variables.
Sure. This is the decision variable. This is my decision variable, sir.
Okay.
Colored blue, and then these are
Okay.
my constraints.
All right.
So, in like Erwin, I want also to graph my solution so that I
Okay.
can better appreciate it.
All right.
So I made it like this, and then I
Before
put.
that, can you please, what's the formula for one lang, ano?
Yes, sir. I
Just
just put
number
one
one.
para
Okay.
it's just simulations. There are people
Okay.
that coming into that schedule, sir.
That's one. Okay. All right.
So that's one. I plotted it my constraints, and then I
Okay.
have this formula.
All right.
Some product.
Could you please press F2?
Yes, sir.
Okay. So take a look at what Jobil did, you know? What she did was to identify yung S1 dun sa K37 niya, she placed a number 1 there. And then also in P37, she placed a number 1 there. So this is a good technique. It's similar to what Erwin did a while ago. And then what Jovel did was to get the sum product of that row 37, that's K37, P37, and sum product with the
My decision
35,
variable.
yeah, K35, P35. So whatever value you get there in your decision variables, it will be multiplied. It will be multiplied and then added, summed up to your row 37. Okay,
Yes, sir.
that's okay.
So that's what I did for
Okay.
all the constraints. And then I used the solver, sir. So
Okay.
Erwin and I got the same answer.
All right. So by the way, Erwin and Jovil, Jovil, could you kindly show your solver, please?
My
Data.
solver.
Go to data
Okay, sir. Here.
and then solver. All right. So
I
when
think
you submit your solution for example for your case study,
okay.
okay, yung set objective, kindly click it, Jovial, kasi hindi siya makita, naka-grayed out.
Oh,
Di ba? Naka-gray out siya, di ba?
yes,
So,
sir.
and kunyari, go to Simplex. I-click mo na lang yung Simplex.
This one, sir.
Oo. Click mo siya.
Okay.
Okay. Hindi. Click. Para, dapat makikita yung word na Simplex. No? So, siguro, maybe go to changing cells. Click changing cells.
Changing cells here, sir.
Just click there at the end of the changing cell.
This one.
Yan, yan, para kita siya, di ba?
Okay.
O, di ba? Kita rin yung you can see now the set objective. It can be seen. Okay, what I want here was for you to print this. So control out
Okay.
print screen,
Control
out
oh,
print screen.
Okay.
Okay, and then close mo na siya, close mo. Okay, and then control V. There. Okay, so when you submit your work, guys, class, I want to see this. Okay, this will also save me time in when I check your work. This will also save me time in knowing what was your objective function, right? What was your decision variables, your constraints. Okay, so you get the point, class?
Yes, sir.
Okay, kasi if I have to open the, for example, I'm correct, I'm looking at your work, and if I have to open the solver parameters, that will take me some time still. All right, so thank you. Thank you, Jovial. Okay, appreciate that. So one last, Earl. Earl.
Hola. Yes,
Hola,
sir.
Earl. How are you?
Yes, sige po, share
Okay,
ako.
so we can see here different ways to do it, no? Iba, Jovial's
Ah.
and then was kind of the same, pero there are different ways to do this. So okay lang din yung okay yon, no? Iba naman yung ka Erwin, no? Let's see what Erwin did.
So yun, sir. For the decision variables, I use
Okay.
light blue.
Okay.
So ayun yung given 3 to 11, 0, 10.
Okay,
So,
wait, Erwin, Earl, sorry, Erwin ako. Earl. Okay, take a look at the solution of Earl and the solution of Jovin or Erwin. You notice that they're different, diba? Different number of people to report at Schedule 1, at Schedule 2, at Schedule 3. Jovil, how many employees to report at Schedule 1 sa'yo, in your case?
3, sir.
And then Schedule 2?
13.
13. Okay, you can see the difference now. Okay, this indicates that there are alternative solutions. For as long as our objective function, objective function 35 is the same. So
Yep.
We're saying that there are alternative solutions, but the objective function should be the same for all, if we're to minimize this. Okay, so Earl, kindly continue, please.
Ayun, so decision variable is already checked in the light blue. For objective function is basically the summation of
Okay.
our decision variables.
Okay.
So for the left hand side, basically it is the 8-hour shift. So I named it 8-hour shift. Basically Sched 1, Sched 6, Sched 1, Sched 2, so on and so forth. So the function for this is basically addition of the shift.
Could you please press F2 dun sa X, ano mo? In
F2.
X7.
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 F2.
F2.
Yes.
So it's the sum of you.
Sched 6 and Sched 1.
Okay, all right. So you can
And
see here.
so
Okay, you can see here that what Earl did was to sum the decision variable for Sched 1 and Sched 6. Okay. So
Yep.
as long as the equations are okay, we will not have any problems. Although doble yung sum mo, no? Sum na tapos plus pa.
so
Naninigurado ka, Earl.
ano pa, sir? Sorry.
Yung X7 mo. Sum na,
X7.
may plus pa, no?
Ay, sorry.
Naninigurado ka.
Sorry.
But that's okay, it's okay. Okay lang yun. Natuwa lang ako na may sum na may plus pa. Okay.
Ayun.
Sige.
So for this one, addition lang siya. Then for the minimum employees, the right hand side, basically it is the minimum employees. So for the solve parameters, set objective is the total. The changing variables is the light blue. For
Okay.
the constraints, we have the left-hand side for the number of employees in 8-hour shift. Then the right-hand side is basically minimum number of employees required.
Okay.
And I've used non-negative since the sked here is non-negative, and simplex linear to have linear integer constraint. So the total is 35.
Although you did
Same
not
as
use integer there. No?
yep. Yeah.
It's okay. It's okay.
I can add the man integer. Yeah. Add. Ay, sorry. Pero yun,
Okay, anyway, sige. Yeah, ako na mag-discuss.
sige sir.
Okay. All right. So you also have 35, no? Okay, good. So how about the rest? I hope you got 35. Any questions before I proceed? Were the others able to also generate a solution of 35? Feedback, please, class. How about the others? Did you get 35 also? Hello? Let me check. Rex, kamusta? You won?
No pa po, sir.
No pa? Any questions? Any clarifications? If you have questions, class, please feel free to ask questions. Don't be ashamed. Nicole, did you get it?
Still working pa po.
Working. O, sige. Sige. In case you have any questions, clarifications, please feel free to ask. Okay, so let me share my screen back. Okay. So there are different ways to do this. I just did a simple solution, quite similar to Earl. Okay, so this is my decision variables. So initially, this was empty. Okay, and then our objective function was simply to add the number of employees. And then, so this is our decision variables, this is our objective function, and the constraints, we're told that they should be those that report for work from 1 to 4, which is S1 and S6. Okay, so what I did was to, okay, so I just named, let me just increase the, for us to see. I just gave these names, okay? Schedule 1, Schedule 6, so that when I use the formula, I can do a check. The only disadvantage of this is that I will have to type each of the formulas here because I cannot copy this. Or I can copy this down and then just change the schedules, okay, to save on time. But these are now based on like this: Schedule 2, Schedule 3, the sum of them. This is Schedule 3 and 4. This is Schedule 4 and 5. This is Schedule 5 and 6. Okay. All right. Then we know the right-hand side is this one. Okay. And then this is my solver parameters. Now, how do you include the integer? The integer class should be based on the decision variable. It is the decision variables that are integers, okay, and not the right-hand side or the left-hand side. It is the decision variables. And now when you do ILP, integer linear programming, you'll not be able to generate the sensitivity report. Okay, so for our purposes, do not impose first the for your case studies, do not impose the integer linear programming requirement because you will be required to include the sensitivity report in your discussion. Okay. So again, when you submit your let's say cases or your case or your case study or the case study that I'm going to provide you, make sure that you do it this way. Of course, the initial one will be you have to define your decision variables. It should be clearly defined, and then the objective function, and then the constraints, and then the model itself. Okay, and then also include the solver parameters. so that when I check your work, I could easily I could easily check. I could easily refer to the parameters for your work. Okay. All right. So this takes care of. Okay. Let me just redo this. So let me go to data solver. Okay. And there are many ways to skin a cat class. This is one way. So my objective function is here. And please take note of the color coding and the border. Okay. The purpose uh, is for not only for aesthetics, but for easier reading of the model. Okay. So here, my objective function is in bold border and then red font. My decision variables are in, yung border niya are in dash. It's like dotted lines, okay? And then this is minimized. Changing cells is this one. And then my constraints is, as I said, let's not put integer first, but this is this one. Okay, the employees, the decision variable should be integer. And also the right-hand side is the actual number to report should be greater than the minimum number of employees. Okay, minimum number of employees required. So that's this one. Okay, this one. And then it should be simplex and not GRG nonlinear or evolutionary. This will be used later on when we go to nonlinear programming. All right. And then, of course, as I said, do not anymore click the show iteration results. Okay, so that the solution will be, okay, there's my solution 3, 2, 11, 12. Some of you might have different answers for the number of employees. However, if we check, the constraints should have been satisfied. Okay, 3, 3 minimum. Okay, there should be a minimum of 3. So you'll notice that all of these are minimums. There are others that are more than the required, but this will give us a solution that is the minimum, okay, that will be able to address the minimum required. So 35 is the minimum number of employees that will be employed, and then they will be reporting at these different schedules. Okay, so for some of you, you have a different answer, but we should have the same objective function. Okay, 35. Okay, are there any questions about this? May I request you to please chat if it's clear so far? About the others? Feedback, please. Unless you have clarifications. Okay, thank you. All right. Okay, please feel free to ask questions, class. If not here, if you don't like to ask questions here, you may chat me for clarifications. I'll be more than willing to help you with the model. Okay, by next meeting, I'll be already giving you your first case study, and then I'm thinking of grouping you into groups of 2, so that for the case study that you're going to do will be done as a group. All right. So let's go here. Okay, what's your preference? Diet problem, blending, or inventory problem? Maybe let's go first to this. I think is quite easy. Okay, let's go to, what do you want? Blending, inventory, class. Did you try these problems? Okay, maybe let's go to, okay, any daw, sige. All right, maybe let's look at the blending problem. Okay, LP is very much used in problems that involve mixing of ingredients, of chemicals, to come up with a particular blend of a product. So we have this case where this company feedstock, this company produces several types of feeds, 4 types of feeds. And then each of the feed have certain percent of nutrients in it. So the main ingredients are corn, grains, and minerals. Okay, so for example, for feed 1, the content is 30% grain, while for feed 4, it's 10% corn. Okay, and then feed 2 has the highest number of grain, and this is actually for specific dietary needs of feeds for, what is this for? I think for chicken or various farm animals, and also minerals. Okay, and then we have the cost to produce each of them. Okay, so feedstock has just received an order from a local chicken farmer for 8,000 kilograms of feed. So there's an order for 8,000 kilograms, and the farmer wants that the feed to contain 20% corn, 15% grain, and 15% minerals. Okay, so the company, how should it combine its feed so that it will have this combination of corn, grain, and minerals? Okay, and then it has to be at a minimum cost. Okay, so this is an example of blending problem. Okay, so I just wanted to tell you that I think it's BMEG of San Miguel Corporation that they use this. Okay, they use this. So these are not models that are just textbook or just for classroom purposes. I know I know personally the head of the operations research of San Miguel. She was the operations head of San Miguel for a long time, and then they would use this. They would use optimization, and even the joke is sometimes, so they were able to come up with a perfect formula, a perfect blending problem. Okay, very good. The nutritional requirements were met at a minimum cost, but there was a problem. What do you think the problem was? And this is true. This is a true story. So they would combine, they would come up with an optimal solution, optimal mix, a problem like this. And they would compute for the amount of the ingredients so that it will be blank percent like this, blank percent like that. And then the cost should be minimized, okay? And they were able to solve that. However, what was the problem, class? Any guess? What do you think was the problem? Anyone? Okay. The taste. All right. Yeah, related to that, Erwin. Thank you. The farm animals did not eat it. So yeah, it was related to the taste. So I don't know how I failed to ask my friend what they did with that situation. Okay, maybe they added some flavoring for that. So I think they added another dimension here, flavoring, a certain percentage of flavoring, so that that will be addressed. Okay, but that was an interesting problem, and that was an interesting application of a blending problem. So what we're doing here they're not just theoretical; they are actual problems that are being used in companies. And so your case study, the case study that you're going to write is use a company, and then you're going to write a possible application of an LP. So it depends on the company that you're choosing. It can be a manufacturing problem, a scheduling problem. Okay, but please do not just copy the problem from the internet. Okay, so you have to do a little research. Okay? In particular, it's best for you to use your own company or your friend's company so that you can interview that friend and ask about potential application of LP. All right. Okay, so let's go through the process. Let's first identify our decision variables. So what do you think are our decision variables here? So in order to address this requirement of this farmer for 8,000 kilograms of feed, okay, the farmer wants 20% corn, 15% grain, and 15% minerals. Okay, take note that this will be coming from, it will be coming from combining feed 1, feed 2, feed 3, feed 4. So they have this feed, and then they'd like to combine it in such a way that it's like a made-to-order thing. They combine it so that it will have 20% corn, 15% grain, and 15% minerals. Of course, the cost should be minimized. Okay, anyone, class? What will be the yes, Erwin? Thank you.
I think, sir, the decision variables are the number of kilograms to be produced per type of feed.
Okay, the number of kilograms
Yes,
be
sir.
to be produced.
Or to be produced, sir, per type of feed. So since there are 4 feeds to choose from, so there are 4 decision variables, sir.
Okay, so there are 4 decision variables. So what will be the first decision variable?
The number of kilograms to be produced for feed 1. Then the next is the number of kilograms for feed 2. Then the
Okay.
number of, yes, sir, the number of
Alright.
kilograms for feed 3.
All right, but we're not going to produce feed 1, feed 2, feed 3, feed 4. Okay, so let me just clarify this. The feed 1, feed 2, feed 3, feed 4 are already present, existing na sila, no? So the company has that. So it's a matter of combining this, blending them. So perhaps the verb to use is not to produce, but rather to use. Okay, so it's a blending problem. We will be getting from feed 1, feed 2, feed 3, feed 4, combine them so that the requirements are met. Okay, so Erwin is correct. So what do you want to use? Maybe let's just use feed 1. Feed 1. Okay, so let me highlight this and make it 18 so that you can see. So feed 1 is, what will be feed 1? It will be number of what? Or number of class? Number of what? So we're going to use feed 1 up to feed 4 and mix it so that we have this this requirement by the farmer: 20% corn, 15% grain, 15% minerals. So the items are in kilograms, right? Percent of nutrient in feeds per kilogram. I think this is percent of nutrient in feed 1. Okay, so this is percent, right? Parang kulang tong ano. It looks like it's lacking. Percent of nutrient in feed 1, percent of nutrient. I think this is per kilo, per kilogram. So 1 kilogram of feed 1 contains 30% corn, 10% grain, and 20% minerals, and the cost is 50 pesos. Okay, so this is also per kilogram. All right, so we would like to determine for feed 1 the number of what? The number of kilograms, right? To use in the mix. Because we're going to come up with the mix. Okay, is this clear, Cass? Number of kilograms, let me, of feed 1. So this is feed 2, feed 3, feed 4. All right. So feed one, we call feed one as the number of kilograms of feed one to use in the mix. Okay. All right. Any questions about our decision variables? This is what we want. Clear ba so far, class? Our decision variables. Okay, what will be our objective function then? Is this a minimization problem or maximization problem? Okay, thank you. Clearly, this is a minimization problem, di ba? Kasi what's given is, we're not given the contribution margin. We're given rather the cost. So we would like to have an output of 8,000 kilograms of feed at the least amount of cost. So this is a minimization problem, means Z is equal to. So how will our objective function look like? We're given the cost. We're given the cost. So that's 50, and then that's 60, 64, and then 30. Okay, so this is 64, 50 times. So we used feed one. Right, plus 60 times feed 2 plus 64 times feed 3, and then another sum 30 times feed 4. All right. So does our objective function look okay? So this is our total cost. Let's just identify this to be our total total product cost. Product. Okay. So we now have our objective function, and then we now write subject to. So these are now our constraints. Okay, what will be our constraints, class? Okay, yes, Erwin?
The first constraint is the order quantity, which is 8,000 kilograms, sir.
Okay, 8,000 kilograms. And how do we write that? The order
Um,
quantity.
The total of feeds, sum of feed 1, 2, 3, 4 should be equal to 8,000, sir.
Okay. You agree, class? When we add feed 1, feed 2, feed 3, and feed 4, the total of that should be 8,000 kilograms. Right, class? Okay, yeah. Thank you. So the total of feed 1, feed 2, feed 3, feed 4 should be, okay, it's difficult to write here the insert. Let me see the sigma. Oops, symbols. This will take long, no? Kung isa-summation ko pa. Let me just use my draw. Okay, so this is subject to. Okay, sum, just the sum of our feeds feed sub I, of course, feed sub I ranges from 1 up to, we have 4 feeds, right? The sum of them should be equal to 8,000. Should it be a strict equality, class? So this means feed 1 plus feed 2 plus feed 3 plus feed 4. Oh, I think I better write that. So this is feed 1 plus feed 2 plus feed 3 plus feed 4 should be equal to 8,000. Should this be a strict equality, class? What do you think? Should be.
I think, sir, it can also be greater than or equal to 8,000 since that is the minimum. But the result will still be 8,000 since this is a minimization
Yeah, that's true.
problem.
Correct. Okay, so we can actually make this greater than or equal to 8,000. But since this is a minimization problem, it will still revert back to the 8,000 because any amount in addition to the 8,000, unless there are constraints, intervening constraints that will make the total to be more than 8,000. Okay, but in the absence of any qualification whatsoever, we'll just make use of the strict equality. So this is the total order, right? Total order for the feeds, no? For the mix. Okay, so that's the first constraint. Okay, what are the other constraints? Yes, Rex. Thank you, Rex.
Try lang, sir.
Yeah, go. Sige.
Summation of feed 1 to feed 4 corn greater than or equal or greater than to 20%. 0.2.
Sige, paano yun? Paano yun? Summation ng
feed 1 to feed 4 corn equal or greater than 0.2.
Okay, how do I write that? Sum ng feed
1 corn.
Feed 1 corn. But what's feed 1 corn? What's feed 1 corn?
0.3.
Okay, sige. Tingnan natin. You're correct, no? What's the meaning of 0.3 here, class? Si feed 1, okay, 1 kilo of feed 1. So if I get 1 kilo of feed 1, so this is feed 1. Feed 1. This is 1 kilogram, no? 1 kilogram. How much corn will we get here? For feed 1. Okay, yes, Earl, thank you. You have, yeah, that's 300 grams or 0.3 kilograms, right? For every 1 kilogram of feed 1, you'd be getting 0.3 kilograms of corn. Why? Because it's 30%. Okay, 30% component. Okay, so let's first take a look at suggested by Rex. No, let's take a look at the corn component. Let's elaborate on the on what Rex was saying about the corn component, because Rex is right that we have a certain constraint as far as the content of the mix as far as corn is concerned. So the question is, where will corn be coming from? Corn will be coming from feed 1, right? And also feed 2, and also feed 3, and also feed 4. Okay, they differ in as far as the corn content is concerned. Feed 1 has the highest corn content, while feed 2 has the lowest corn content. Okay, let's take a look at it in terms of 1 kilogram. So as I mentioned a while ago, 1 kilogram of feed 1 contains 0.3 kilograms of corn. 1 kilogram of feed 2 contains 0.05 because this is 5%, right? Feed 3, for every 1 kilo of feed 3, it will contain 0.2 kilos of corn, etc. So what we can do now is to, of course, add all the corn contents, right? We can now add all the corn contents. Okay. So how much corn are we going to use for feed 1? Are we going to generate for feed 1 class? How much corn? Okay, I have an answer here. 30% for feed 1. Okay, but my question is, how much corn are we going to generate for feed 1? Okay, okay, it will refer to how much feed 1 are we going to how are we going to use? Class. How much feed 1 are we going to use? We defined that already, di ba? We're going to use feed 1, kilos of feed 1. Sorry for the redundancy, no? So feed 1 refers to the number of kilos of feed 1 to use. All right? So we will be using, for feed 1, we will be using, okay, we will be using feed 1 kilos, right? I think I should have used another name, but it's okay. We will be using feed 1 kilos. So whatever kilos this is, that remains to be seen. So how many kilograms of corn are we going to generate from this one? How many kilos of corn? So that should be plus 0.3, okay, times feed 1. Right? This is the number of corn in kilograms that will be generated from using feed 1 kilograms. Do I make sense, class? Tama ba? Is it correct? 1 kilo of feed 1 will generate 0.3 kilos of corn. Therefore, feed 1 kilograms of feed 1. I should have used another variable. Feed 1 kilograms of feed 1 will generate 0.3 times feed 1 kilograms of corn. Is it correct, class? So this is the corn component of feed 1. 0.3 times feed 1. And of course, feed 2, we add 0.05. 0.05. Why 0.05? Because it's only 5%. 0.05 times feed 2. And then we have 20 and 10. So we have plus 0.2 times feed 3. And then plus 0.10 times feed 4. All right. What's this, class? What is this? If we add all of this, okay, naghang yung ano, wait ha. Naghang yung pen ko. Ayaw ah. Ayaw niya mag-erase. Okay, anyway. All right. So, what's this class?
Sir, that's the total kilograms of corn.
Okay, that's total kilogram of corn that will be present in the mixture, right? Because the mixture is feed 1 plus feed 2 plus feed 3 plus feed 4, right? We're going to combine them, right? So this is the total corn that will be present in the mixture. But what's the constraint here? What's the constraint, class?
It's an sir percentage.
Okay, so
So we need to divide it by the total number of kilogram of all the feeds to be used, sir.
okay, so but wait, let's take a look at the corn requirement. Ilang percent daw yung corn?
20.
20%. Okay, so how do we put that in an equation here? How do we now indicate here, or how do we now present this as 20% corn? This will only give us the total kilograms of corn, right? How do we now present this to be 20%? What do you think, class?
Greater than or equal to the sum of 0.2 times sum of all feeds.
Okay, which is at least, all right. So, who was that? Sorry, who
Earl
was
po.
Earl? Okay, Earl, what were you saying? So it should be greater than or equal to what?
0.2 times the all of the feeds, sum of all the
Okay, why is not pen? My pen is not
total feed.
working. Okay, hindi lang ah. Pinag-work na naman yung pen ko. So, Earl is suggesting that this should be greater than or equal to what?
0.2
0.2.
times total feed.
What's the total feed?
1 kilogram, not sure.
Sir,
1 kilogram ba? Yes.
ay,
Yes?
sorry sir, question lang to.
Yeah.
I think, I'm not sure if ako lang for if ever. Pwede pong pa-clarify lang ng problem kasi like, I get na up to 8,000 kilogram of feed pag add si feed 1 to feed 4. But what happens if we add feed 1 and feed 2? Does that mean 35% corn or paano po siya?
Sorry, again. Sorry, I didn't get your question, Rex.
How does adding up the kilogram of feed translate po dun sa corn content nila?
Okay, yeah, good question. No? So, the problem says that corn will be coming from feed 1, feed 2, feed 3, feed 4, right? Tama? Tama
Yes,
ba,
sir.
class? So, we're going to mix. Okay, drawing na natin. So, we will now have, this pen is really terrible. We will now have a mix. I don't know what happened to this one. It wasn't like this before yung drawing pad ko. We will now have this. This is the product. No? This is the final product. And what does this consist of? This consists of how many kilograms? The order is for 8,000 kilograms, right? Tama? Class?
Yes, sir.
And this 8,000 kilograms should have, the content of which should be 20% corn. And what else? 20% corn, at least 20% corn, and then 15% grain, at least 15% grain, and at least 15% minerals. All right? 20% corn, 15% grain, 15% minerals. Okay, how are we to generate this this mixture? we're going to include here feed 1, feed 2, feed 3, feed 4. Okay, we're going to mix feed 1, feed 2, feed 3, feed 4, so that the total, if you take a look at the first constraint, our first constraint is the total feeds that we're going to mix should be equal to 8,000 kilograms, right? So feed 1, feed 2, feed 3, feed 4 should be 8,000 kilograms. Now the question is the proportion. Okay, how many kilograms of feed 1, how many kilograms of feed 2, feed 3, feed 4, so that the corn should at least be 20%. Okay, it can be more than 20% because it's at least 20%. So we have to make sure, for example, if it's to be 20% corn, maybe because feed 2 has only 5% corn, maybe this mixture should be less, there should be maybe more feed 1 or feed 3, because feed 1 and feed 3 contain the most number of corn, right? And corn is the biggest content that we should have in this mixture. Okay, so this is how the product should go. We should produce 8,000 kilograms, and this 8,000 kilograms is just by adding feed 1, feed 2, feed 3, feed 4. Okay, and we have to make sure that if we add this, because feed 1 will give us a certain percentage of corn, a certain percentage of grain and minerals. Also feed 2, feed 3, feed 4. We have to make sure that the mixture should have at least 20% corn. But how could we design it in such a way that 20% of the 8,000 should be corn? That was what we were answering, diba? Where will corn come from? Corn will come from these three feeds: feed 1, feed 2, feed 3, and feed 4. It will be coming from those, I mean, 4 feeds. All right. In fact, we wrote it here. 1 kilogram of feed 1 contains 0.3 kilograms of corn. Okay, since we're going to produce feed 1 kilograms, okay, or mix feed 1 kilograms, then to get the corn content here, we multiply 0.3 by the number of kilograms of feed 1. Also, multiply 0.05 with the number of kilograms of feed 2, etc. So this will now give us, the total of this will now give us the kilograms of corn. Are you getting me, class? 0.10 times feed 4 will give us the number of kilograms coming from feed 4. But what we need is not the kilograms of corn, but the percentage of corn. Okay. So mathematically, how do we get the percentage of this? How do you get the percentage? It should be 0.2. That's very simple. It's only ratio. Yes, I think I saw here a chat. Z, the objective function. What about the objective function? Did you just mention that now? The objective function.
Yes, sir, kasi I think kanina Earl was mentioning that we need to multiply 0.2 by the total number of feed.
Okay.
Yes, sir.
So,
Sir, I think in our solution we refer to Z as the objective functions or the total number of feeds, sir. That's why I mentioned it.
all right. So, if we're going to measure, okay, if we're going to strictly say that it should be 20%, how do we make sure that it should be 20%? How? Okay. How do you get this proportion? The 20%. It should
Sir-
be,
Sir,
yes,
maybe 20% of the 8,000, which is the
yes,
required
yes.
number of kilograms, sir.
Correct. That's what Earl or Erwin was saying. And tama, no, that's correct. So 20%, multiply that by 8,000. So that's 1,600. Correct, class? And that will give us the corn content.
Yes,
Tama
sir.
ba, class?
Yes,
Because
sir.
we can say that 20%, uh, 20, in order for the content to be 20% corn, it's the same as saying that the corn should be 1,600 kilograms. Are we correct there, class? Tama ba? Is my explanation clear? Kasi ito, the point 2 here is in terms of percent, right? But if you're going to translate that in terms of kilograms of corn, and why do we need to translate that, class, into kilograms of corn? Why am I multiplying this by 8,000? So you're correct. It should be multiplied by 8,000, making this now 1,600. But why are we making this equal to 1,600? Why are we converting it into kilograms of corn? What's the reason for that? I know you know the answer. Why are we converting it into not percentage, not the proportion of corn, but rather we converted this into the weight of the corn, which is 1,600, and not the proportion of the corn, which is 20%. Why are we doing that? Is it the constraint given to us in terms of proportion, 20% of corn?
Sir, para same yung units ng left hand side and the right hand side, sir.
Exactly. Thank you, Erwin. So that's what we call, that's what we discussed last time, the dimensional consistency. Okay, dimensional consistency. Actually, class, we can still maintain the point 2 if we want. However, we have to divide everything by 8,000. So this right-hand side, if we divide everything by 8,000, then that's perfectly fine. This will now be 0.2. Okay, so what we want here is that we have to make sure that the left-hand side and the right-hand side are equivalent. Otherwise, if we just maintain this to be 0.2 and not divide this by 8,000, then it will be dimensionally absurd and dimensionally wrong. We will get a totally wrong solution. Okay, so I just wanted to underscore that when you're crafting or setting up your constraints, make sure that the left-hand side of your constraint and the right-hand side are dimensionally equivalent or consistent. If the left-hand side is in kilograms, then the right-hand side should be in kilograms. Hindi siya pwedeng proportion na 0.2. Okay? All right. So I think you got the idea here. This will be our first constraint. That 0.3 of feed 1, which is this one, 0.3 of feed 1, plus 5% of feed 2, plus 20% of feed 3, plus 10% of feed 4 should be greater than or equal to, the minimum is 0.2, but this is in percent proportion. We have to multiply that 0.2 by the 8,000 that we're going to produce. So 8,000, multiply that by 0.2, that gives us 1,600. Okay, and so we'll be able to create also our constraint for grain and minerals, right? So that will be just the same. So this should be 0.10 for the grain, 0.10 times feed 1 plus, let me just write in small letters, 0.3 times feed 2. And then what's the next one, class? Could you kindly dictate, please? What's the next one for feed 3? And then feed 4. What's the proportion for feed 3?
15%, 0.15.
Okay, 0.15 for feed 3
0.10.
And then point
Point
10. Okay, thank you. Point 10 for feed 4. And this should be what? This should be
Greater than or equal to
greater than or equal to
1,200, sir.
Is it 1,200?
I mean, 15% times 8,000, sir.
Yeah. Oh, tama, tama. So 1,200. How did you get 1,200?
Multiplying the 15% of 8,000, sir.
Correct. Thank you. That's correct. So that's 15% of 8,000. So this is the minimum requirement. Let me put here. Minimum requirement for grain, right? Sorry for the handwriting class. My digital pen is not that. It used to be good. Now it's, I don't know, because maybe it's depreciated. So minimum requirement for corn. All right. Minimum requirement for corn, and then lastly, okay, which I will not write. I'll just leave it up to you. So that's 20.20 or 20% times feed 1 plus 20% feed 2 plus 20% feed 3 plus 30% feed 4 should be greater than or equal to also 1,200, and that's the minimum requirement for minerals. Okay, so that takes care, class, of the requirement for corn, for grain, and for minerals, right? Are there any other constraints, class? Any other constraints? So we were able to identify the constraint as far as the weight of the mix. Okay. All right. So Erwin mentioned that also, okay, there should also be non-negativity constraint, because nothing in the constraint that we wrote will prevent the solution from becoming non-negative. So that's correct. So our constraint should be feed sub I should be greater than or equal to 0, where we define I to be equal to from 1 to 4. Okay, so that's feed 1, feed 2, feed 3, feed 4 should be greater than or equal to 0, and it's a non-negative. Okay, and then of course, this is not an integer linear program. Okay, and even if this was integer linear programming, we would not include it at the moment. Okay, but later on we will include it. All right. So, any questions? So let's now solve it. Okay, let's now come up with our solution, and then I'm going to use this Control C. Let me put it here. Okay, Control B. All right, sumama yung mga handwriting. Let me delete this. Okay. All right. So, of course, class. So maybe I'll give you 10 minutes to work on your LP. Okay, and then we'll ask some of you to, those of you who have not shared, I'll ask some of you to share your model. Okay, so just make sure that we follow the quote unquote protocol in our models. So the decision variables, the objective function. Let me put this line 1 so that it will be. Okay, I place it in line 1 here. All right, so let me pause for a while our recording. Pause. All right. Sige, in the interest of time, class, I'm sorry I have to present now kasi we're nearing time and I'd like to finish this. Okay, so let me, oops, share screen. Okay, this is the answer that I got. So let's first compare. Did you get 390,000 feed cost?
Yes,
Yes,
sir.
sir.
Okay, good, good. All right, 390,000. Now, next meeting, we're going to discover how to determine if there are alternative solutions. Because did you get this quantity mixture also?
Yes, sir.
Okay, let me see. Where's the control V? All right, always. Okay, this one. Okay, so let's take a look at how I did this. Of course, there are different ways to do this. Okay, and I think that I hope that my model is clear. Okay, one of the objectives, class, in coming up with the model is that where possible, it has to be the cells as much as possible have to be compact. Okay, and then it has to be understandable. Okay, so here I have the title feeds. Okay, so these are our decision variables. Okay, initially this was, let me delete this. So this was empty at the start. And our objective is to minimize the cost. So I'm given the cost here. Okay, I'm not going to just get the total cost. I've included here the cost per feed or feed cost. Okay, because I know that from a managerial perspective, it's also important to know how much is the cost for feed 1, feed 2, feed 3, feed 4. Although this is not required in the problem because the objective function only calls for the total cost. However, we have to discern if there's a need to get the components of the cost, and I believe that you'll agree with me that it's also relevant to know how much the cost for feed 1, feed 2, feed 3, feed 4 is. Okay, so this is our decision variables. So we just stick to the rudiments of creating an LP. And then I have here the objective function, which is just the sum of my feed cost. By the way, my feed cost just came from, I could have named this feed 1, feed 2, feed 3, feed 4. That could have been fine. Okay, so it's just 50 times feed 1, 60 times feed 2, etc. So this is 60 times feed 2, etc. So you get the total of this. The sum of this will be our objective function. Okay, then for the constraints, okay, always make sure that your left-hand side is also color-coded. Our left-hand side here is the sum of feed 1, feed 2, feed 3, feed 4. That's the left-hand side. And the demand is 8,000. Okay, so this is the left-hand side. Now, units, it's not actually produced, but it's mixed, or the weight total mixed. Okay, and the demand is 8,000. So this is the right-hand side, this is the left-hand side. And we also have the left-hand side for the weight of the corn, of the grains, and the minerals. Okay, so we have this given. And then I wrote here the minimum proportion. Corn should be 20%, grain should be 15, and the mineral should be 15. So how do I get the content? Okay, so I just multiplied the feed, okay, the feeds with the percentage to get the corn, and then I copy this down to get the grain and the minerals. So this is our content in kilograms, and then minimum required is, how did I get this? It's simply the minimum proportion multiplied by the demand. Okay, so we have here 161212. Okay, we could have written this one on top, no? Produce a cell or generate a cell where all the absolutes can be placed in one portion, and then everything here will be linked to that. All right, and then so the solver parameters will be, to take a look at this, let me just show this to you. Okay, notice that everything I can see here. Objective is BJ5. There's objective here, BJ column 5, this one. Okay, and we know that this is just, that's the sum of the feed cost. So we have placed here total cost. Okay, it's an identifier. So this is our total cost. And then it's to be minimized. Changing cells is this one, BF3 to BI3, this one. And then constraints are what's this? BJ3 is equal to BK3, this one. The total mix should be equal to 8,000. That's one of our constraints. And then also this one, BK9 should be equal to BL9 to 11. Right, so this one, BK9, this one should be equal to BL. Right, this is the left-hand side, and this is the right-hand side. You notice what I do is, as much as possible, I put my left-hand sides and my right-hand sides close to each other if possible. Okay, so let me show this data, solver, and then this is my solver parameters. Objective is BJ5, this one, all right? Minimize, and then our changing cells is this one. And then the constraints is total mix is equal to the demand. Okay, and the content should be greater than or equal to the minimum required. The non-negativity is here. Make unconstrained variables non-negative. And then we're using simplex because this is LP. And then solve. So we can have here sensitivity, answer report, we can generate this. And then again, important to understand what this is. Okay, always practice class what the meaning of this sensitivity, especially the reduced cost and the shadow price. Okay, so going back here, our solution is we mix 4,500 kilograms of feed 1, 2,000 kilograms of feed 2, and then 0 grams of feed 3, and 4 kilograms of feed 4. All right, so let me copy this. Let me generate a new copy. What if, let's say that there's another requirement that there should be, let's just modify the problem a bit. There should be at least 500 kilograms of feeds 500 used per feed. Okay, so there's another constraint. We're told, because here we're not going to use feed 3. But let's suppose that we are required that the minimum feed to be used is 500. Okay, so let me just put here minimum feed, minimum weight per feed is 500. Let's suppose this is another constraint. All right. So if this is an additional constraint, then what will happen is that we will have to constraint that the weight of the feed should be at least greater than or equal to 500, right? So we will have to add this. Notice I just created another copy of this to preserve the other one. Okay, so data solver, and we will just add a constraint here. The constraint to be added is that, okay, let me cancel this first and close, and then let me delete this. Okay, so that in the answer report, the original is 0. All right, solver, same objective function, same, this one, same minimization, same decision variables. But for the constraints, we will add that each feed, this one, the minimum of which should be 500. All right. The minimum of the feed should be 500. Okay. So you can now see that we have this additional constraint. The minimum is 500. So same thing. Same thing. Right. Solve ko muna, Erwin, and then solve. Okay. Oops. Ano bang mali? Ay,
Kasi
sorry,
sir,
sorry.
you entered
Oh.
sir, less
Yeah.
than or equal.
Yeah, less than. Apologies. Yeah, my mistake. Very bad. Very bad. Yeah, very bad. So solver, that should have been. Yeah, minimum should be. Okay. This should be change. Ay, sorry, not change. Cancel, not add, but change. This should be. Thank you, Erwin, for that. Very careless of me. Should be greater than or equal to 500. Okay. So that should be the minimum, greater than or equal to 500, to make sure that each of the feed should be utilized in the production. So solve. Okay, there you go. Solver found the solution. Okay, and we can see now that the cost will be a bit higher because feed 3 has the highest cost, 64, 397, 625, but it does, okay, it does meet all the requirements. So you have the minimum content for corn, grain, and minerals. Okay, everything is met. And then for the total quantity, 8,000, everything is met. And this is also the minimum cost given this constraint. Okay, so each one of them has 500 kilograms minimum. All right, if we compare it with this one, this is 397. This one, on the other hand, is 390. Okay, in what circumstance could we apply this? What do you think, class? What is a practical scenario when this should be, when the company will have to enforce this constraint? Anyone? Just top of mind, class? Top of mind. This is costly, right? Kaya nga nung unang solution, it was not included. And anyway, the requirements were met, and the total cost was 390. What do you think would be a scenario where the company would insist on this? Anyone? It's top of mind idea. Okay, I'm thinking of one scenario. For example, if there's an expiry to the feeds, okay, if there's an expiry to the feeds and it will be costly for the company to lose this. If they were not using this, and then mag-expire na siya, then the company can impose that this also be used so that they will not have wastage as far as this feed is concerned. That's one possible scenario. Okay, and maybe we can think of others, but we just inserted that. Okay, when I saw the solution, I immediately thought, oh, bakit? Why no feed 3? It was because it was the highest in terms of cost, and we were minimizing the cost. But if there was a constraint to make use of this also, in order to, let's say, prevent any loss of feed 3 because of expiry, then that's a very relevant constraint to put in. All right. So, okay. Was there anything that we learned today, class, tonight? Okay lang ba? How was the pace? Was it okay? And as we progress on really enhancing our LP skills, the next problems will be, of course, more challenging. This is just relatively simple problems. The next ones will be really quite a bit more challenging. There will be more decision variables and more constraints, etc. Okay, any questions, class?
None, sir.
Okay, thank you. I will not anymore start with this one because this will require quite maybe an hour or an hour and a half. This problem on inventory problem. This is quite a long problem, and it will require more time. And it's already 9:11, and I told you that it will be from 7 to 9. Okay, so let me honor my word. Well, I did not honor my word for 11 minutes, so very sorry about that. Okay, so let me stop recording.